You look at a biological system and it's just so complicated, and like, how do I even start? How do I start as a scientist? How do I get into being able to do some work? Many times students have to learn the craft of how to design experiments, how to do good experiments, how to interpret the data on the job.
I really think that we can give students a very concrete way of learning how to go about doing science.
So the question is that how do you prioritize experiments?
What are variables?
Okay, disproving a hypothesis.
Does working mean that you get a result that you're expecting? Does working mean that you just get to a conclusion that is interpretable?
So how much of an experimental protocol do you want to understand before you actually do the protocol?
This course can teach you not only which variables you need to take into account when you are designing experiments, but will teach you things that you are never going to read in a protocol. My name is Ana Ruiz Sáenz, and I work in a lab in which we study the molecular mechanisms that drive tumor formation and cancer progression.
My name is Neil Robbins. I and others were really interested in understanding what environmental factors influence where the root system is going to grow and expand.
I think it's great for young researchers to learn through the efforts of established scientists, because often those case studies can be very meaningful to you as you design your own experiment.
In a lot of ways, it's hard for people to articulate how they develop experimental designs. And so if there are people that are effective at articulating it, it's an opportunity to standardize that training in addition to whatever training you might be getting one-on-one from your thesis advisor or other members of your lab.